Hello everyone and welcome to a new episode of HVAC Education Hub channel. In this episode, we'll cover what is COP, what is efficiency of heat pumps, and what are the main variables to calculate it. Regarding COP means coefficient of performance, and in heat pump or refrigerant system, it is a ratio of useful heating provided to work or energy required. It means it is the ratio of heating delivered to our system by electricity used to produce this heating. This electricity is mainly from compressor, as compressor is the heart of refrigerant system. There is also some other parts like pumps, fan motors, sensors, but this is very low consumption, so we'll focus only on compressor side. Regarding thermodynamic formula of COP, we can see that there are two main variables: temperature of heating system and temperature of source. It means that it doesn't depend on isolation of house, as a lot of people are saying. So you can see that people say that if you have non-isolated house, heat pump cannot work in your house. This is not true. Of course, if you don't have good insulation, if you have high heat loss, as we covered in heat loss episode, and you have higher U value, your running cost will be higher. But COP is not about that. COP is about efficiency. And from experience, you can find very good insulated house, new house with very low COP if system design is not so good. And opposite, you can find old building without insulation with very good COP because system design is good in that house. Let's see some examples. Here we have the heating capacity table of Panasonic 9 kilowatt 3-phase unit. And in that table, you can see that on outdoor temperature of +7 and water flow temperature of 35 degrees, we have 9 kilowatt heating capacity delivered, and our input power is 1.86 kilowatt. When I put this in formula, our COP is 4.8% efficiency. On the same outdoor temperature and same heating capacity delivered, so 9 kilowatt +7 degrees outdoor, if we increase our flow temperature in system and we have 55 degrees flow temperature, for the same amount of heat delivered, our input power is around 3 kilowatts, so 3.06 regarding table. And when we divide 9 and 3.06, our COP is less than 3, so 2.94. It means 294% efficiency. You can see that if we compare 35 degrees flow and 55, difference in COP is 64%, which is very high difference. It means that for each 1 degree of increasing flow temperature, we spend 2 or 3% more electricity or more running cost. This example provides just to see what is the impact if we have higher difference of our system temperature and our source temperature. So when this difference is higher and we have wider range, our COP is lower. So we need to be sure that our difference between heating system and source is low, so our COP could be high. Of course, we cannot interfere on our outdoor temperature. It depends on climates where we are living and day of the year, but we can provide good system design and we can go with as low flow temperature as we can. Also, regarding outdoor temperature, we can see that when outdoor temperature is dropping, our coefficients of performance is dropping because we have higher difference. So for example, for 35 degrees flow temperature and -7 outdoor, our input power is not 1.86, it is 3.16, and for the same heating capacity delivered, so for 9 kilowatt, and our COP is 2.85. It means that it is lower than with higher outdoor temperature. But you can think about that as your car. So you will not base assumption or calculation of efficiency of your car on maximum load when you are driving on maximum speed. You will base efficiency of average consumption, and the same applies to COP. So when we are dealing with calculations, we are not dealing with COP, we are dealing with SCOP. It means seasonal coefficient of performance. And this is for whole heating season where we have average efficiency. So average heating season is not on lowest outdoor temperature. It's on average. So usually it's above zero. So that's why in all calculations, in all norms or recommendations, you will find COP at water 35 and outdoor plus 7 degrees. This is all for today. Hope COP topic is now more clear for you. Thank you for watching. Subscribe on our channel and see you in the next episode.